Something you may see on a test in organic chemistry too is making a carboxylic acid in what we call a side chain oxidation. And in order to do this, you need to know your oxidating agents. And one of the easiest oxidating agent to use would be what we call sodium dichromate, which is expressed like this, and sulfuric acid. So on a test, if you were given something like this, or if you were told to oxidize something and make a carboxylic acid, you can use this here, which is sodium, this is chromate, and this is oxygen, in sulfuric acid. And in order to do this with this particular problem, you have to have what you call a benzylic hydrogen. And if you remember from an earlier video, phenyl is let me draw it down here. Phenyl means you have 6 carbons within a ring. So if you would count these, it would add up to 6. So this would be phenyl. This is really a benzene ring, but when it's talking about a substituent, it's a phenyl group. So when this is a substituent, it's a phenyl, but this is really simply benzene. But in order to have a benzylic hydrogen, which is a little confusing, you have to have 7 carbons instead of 6. So this right here is 6 carbons, which is a benzene ring. If it's a substituent, it's a phenyl. But if you have something like this, which would be 7 carbons, so you got 1, 2, 3, 4, 5, 6, 7, it's a benzylic carbon. And whatever hydrogens you have on it is a benzylic hydrogen, right? So if you had something else on here, this would still be considered benzylic, but this is not part of that, so that's not benzylic. If you were dealing with something in nomenclature that had additional side chain, say if this was nitrogen or something like that, you could name this nitrogen, and this could be the benzylic part and whatever. So, but just know that you have to have what we call a benzylic hydrogen. And if you were to predict the product on a test, and it's a memorization thing, you would have this. So what happened? Nothing happened on this side because you didn't have any benzylic hydrogens. There are no hydrogens on this carbon. You have all methyl groups. This group right here is taken 3 times, so we could express this like that. And these hydrogens right here are not benzylic because they're not attached directly to the carbon. So nothing would happen on this side. But on this side of the molecule, you would remove all of the hydrogens and you would simply make a carboxylic acid. Something you can just know and memorize. No matter how many chains you had on this, if we had something similar like this, I mean, we can add carbons all day long and you would get the same product. All these carbons over here, except the benzylic carbon, gets thrown out in the wash, gets thrown out in solution, and you would still get the same product here. You would get a double bond on the oxygen and an OH, which is a carboxylic acid. So whether it's 1 carbon, 7 carbons, as long as you have a benzylic hydrogen, you would end up getting this product here. Just something you can know There's another way you can make it as well, but this is the easiest way to get the job done.